Welcome to the Explainer. Today, we're going to build the ultimate tool for project control, and that is the Gantt chart. Look, if you're a new engineer, this is your blueprint for turning what seems like a totally complex plan into a successful project. Let's get into it.
So think about it. You're a new engineer, you step onto a site for the first time, and it's just pure chaos, right? You've got moving parts everywhere, timelines that seem to be crashing into each other, dozens of teams. How in the world are you supposed to make sense of all that, let alone keep everything on track, on time, and, of course, on budget?
Well, the answer is actually a single, really powerful visual, the Gantt chart. And you have to understand, this is not just some fancy schedule. No, it's the master plan. It's the thing that takes all that chaos and gives it structure. It makes every single step visible, predictable, and actually manageable.
So how do we build this thing? Well, just like any construction project, you've got to start with a solid foundation. This first part is all about gathering our raw materials, figuring out the what and the in what order for our entire project.
And it all starts with something called the work breakdown structure, or the WBS. I mean, it's simple. You can't schedule what you don't know, right? So the WBS is how we take a massive, overwhelming project and we chop it down into phases, then into smaller work packages, and finally, into individual actionable activities.
Okay, so here are the first three really foundational steps. First, using that WBS you just made, you list out every single task. I mean, everything. Second, you got to identify your constraints. These are the non-negotiables, like a hard must-start on date, or say a requirement from the Saudi Building Code, the SBC, that says concrete has to cure for a certain amount of time. And third, you define the dependencies. That's the logical flow of how work gets done.
And this part right here, this is where we build the actual logic of the project. The most common type of link by far is finish to start. You can't pour a foundation until you've finished the excavation. Makes sense, right? But there are others too, like start to start. You can even get clever and add lag time for things like waiting for paint to dry or lead time to get a head start on the next task.
Okay, so we've figured out the sequence of tasks, but, a plan without people and time, that's just a wish list. So now we're going to add a heavy dose of reality. The who, our resources, and the how long, our time estimates. So, step 4 is all about allocating your resources. This is where you assign your people, your subcontractors, your heavy equipment to each one of those tasks. And then step 5 flows right from that. Based on those resources and how productive they are, you can estimate how long each activity is actually going to take.
And listen, here's a golden rule that every single seasoned project management professional, or PMP, lives by. You never, ever overallocate a resource. You literally can't assign one engineer or one crane to be in two places at once. I know it sounds obvious, but you'd be shocked how often this happens. It's a classic mistake that creates instant bottlenecks, so always check for those resource conflicts.
The math behind this is not rocket science. It's actually really simple. Let's say you have 100 square meters of block work to build, and you know your team can get 20 done a day. Well, 100 divided by 20, that's 5 days. That basic formula is the engine that drives your entire schedule. Okay, this is the fun part. This is the payoff. We've done all that hard prep work, we've gathered the data, we've run the numbers. Now we get to transform all of that information into the visual master plan itself, the Gantt chart. This is where it all comes to life. Actually, building the chart is a pretty straightforward 3-step process. First, you create your grid. All your tasks go in rows down the side, and time, days, weeks, months, runs in columns along the top. Second, you start adding the activity bars, and you make their length match the duration you calculated. And finally, you connect those bars with little arrows, which visually shows all those dependencies we figured out earlier. It's really that simple. So once you have the basic structure, the next key thing to add, this is step 8, is milestones. Think of milestones as the big, important signposts in your project. They're not tasks that take time. They're zero-duration markers for really significant events, like getting a key approval or, the final project handover. They're how you track your big-picture progress.
All right, now for a super crucial step that honestly a lot of people skip, making your chart a powerful communication tool. This is step 9. Don't just leave it as a boring black and white spreadsheet. Use color coding, maybe blue for all the civil work, red for mechanical, electrical, and plumbing, or MEP. Add resource labels and a clear legend.
The whole goal is simple. Anyone should be able to look at your chart and understand the project's status in a single glance.
All right, let's zoom out and look at our finished chart. See, it's more than just a picture. It's a living, breathing tool that you're going to use every single day to monitor progress, spot risks before they become problems, and keep the entire project moving forward.
Now, once your chart is built, your software can instantly show you the single most important part of your entire project, the critical path. This is the longest chain of dependent tasks. Think of it as the project's backbone. Any delay, and I mean even one day, to any task on this path will delay your entire project's finish date. This is where a great project manager focuses almost all of their attention.
And you know, behind the scenes, your software is just constantly running these simple but really powerful calculations. Here are a few key formulas to keep in mind, from calculating that lag time we talked about, to tracking your percent complete, and even those critical code requirements like the 7-day curing time for concrete under the SBC.
So we'll leave you with this one question. Think about your current project. Do you know with absolute certainty which tasks make up its critical path? Because if you don't, you're not really managing the project. You're kind of just a spectator watching it happen. Go find it.